Okay, this is going to be an overview of the Chapter 3 lecture. It's rather lengthy. If you happened to miss class, then obviously you will be at a disadvantage. I'm not going to go into every little detail, and you are likely to miss out on some extra examples and explanations for this lesson. So I don't want these video lectures to be a substitute for actually attending the class. I do think that it does add a lot of things to the discussion, and I do think it gives you more of a background before you tackle these problems in my math lab. But I do want to provide these mainly as an overview. If you're going back and you're just, you want to review what we talked about in class, maybe you're still stumped on something, hopefully these videos will help. All right, so this lesson starts off with a discussion on the centers of measure, and the centers of measure are mean, median, mode, and mid-range. We are not going to really go into mid-range. We're going to focus mainly on mean, median, and mode. So let's jump right in. The mean is also the average, and if you have ever averaged your grades, then you are familiar with the process. Basically, you add up all of your data values, and then you divide by the number of data values you have. And that's the mean. The mean is not always dependable because of a little aggravation called the outlier or outliers that happen to show up in the data set. For example, if you look at the data set 90, 100, 85, 95, 90, 40, 80, 95, and 95. Let's just say that these 9 scores happen to be your grades in a particular class. If you look at this list of grades, this student is pretty much an A student, right? On the 90 to 100 scale, there are a couple of Bs. But what stands out to me is this 40. To me, this 40 appears to be an outlier because it just doesn't appear to belong, right? This student is pretty much an A student. This 40 could be, maybe the student just had a bad day. Maybe the student legitimately didn't prepare. I really don't know what that is, but I really do not think that the 40 accurately reflects the student. And some teachers will drop the lowest grade because of that reason. So let's see what happens when we drop an outlier. Well, if we drop the 40 and we add the remaining numbers, we would, of course, have to divide by 8. And when we do that, we get 91.25. That's without the 40. If we keep the 40, we would add the string of numbers together and divide by 9, which would give us 85.56. So just by dropping the outlier, this student went from having a B average to an A average, which would make a big difference to that student. So as a statistician, you're going to have to decide sometimes, am I going to throw out the outlier or not? Sometimes there may be a valid reason for doing so. If you have ever gone to Zillow or RealTracs, various real estate sites, oftentimes they will tell you the median value of a home in a particular neighborhood. Because if you have a lot of middle-class homes and somebody happens to build, a $2 million home in that neighborhood, that $2 million home would be an outlier, and it would make the average for that neighborhood appear to be higher than it actually should be, okay? So what do? Well, you could throw out the $2 million property, right? And you could just average the middle-class homes. That would give you a more accurate depiction of what's going on in the neighborhood. But a lot of websites, real estate websites, use the median, and the median is the middle value. So to figure out the median, let's go back to our data set. First, you have to list them in order from smallest to largest. So I have those listed here. And then you just find the number that's in the middle. There's a formula for that. The formula says that you add up, you take the number of data values, and then you add 1 and divide by 2. That basically splits the list in half. And we talked about that in class. So see your textbook if you're interested in the formula for that. I'm going to show you how to find the median using the calculator. It's a very easy process, but just know that for now that the median is the middle value. And then we have the mode. The mode is the value that occurs most often. Okay, it's most often repeated. So if you go back to our data list, 95, right? That's the number that shows up the most, so that would be the mode. Okay, let's look at this table here. At first, it may seem to be somewhat daunting. It should look familiar to you. We actually used it in the previous lecture. So we're back to the IQ scores. Remember, we don't know the actual IQ scores, but we do know that they go within a particular range. For example, 2 scores happen to fall into the 50 to 69 range. I have 33 scores that are somewhere between 70 and 89. And then we've got the 35, right? Then we have the 7, and finally there's 1 score that is in the 130 to 149 range. And as we said earlier, if we add these up, we have 78 data points, right? 78 values. But what if we wanted to try to estimate the average IQ score for this population? Well, since we do not know the actual data values, it's going to be fairly impossible to get it exact, right? We're not going to be able to do that. So what do? We do the best we can do under the situation. So to somehow figure out the average IQ for this population, I'm going to use the class midpoint. And we said the class midpoints are 59.5, 79.5, 99.5, 119.5, and 139.5. So to figure out the average, you just average these grades just like you would any others, right? Or these scores rather. So I'm going to say, well, I have 2 times 59.5, right? I would do that. You could put 59.5 in the calculator twice, right? 59.5 plus 59.5, but it's a lot quicker to multiply these out. And then you have 33. You have 33 79.5s and so on, right? All the way down to that final 1 score that's estimated to be about 139.5. And then once we tally this entire numerator, we divide the total by 98. Again, watch the calculator. Do not divide we divide the 78, but make sure that you do not divide the 78 into the last entry, right? We don't want to divide into that last entry only. We want to divide into the whole total. So we estimate that the IQ average for this population is about 92.32. Again, it's probably not that accurate because we do not have the exact data values, but this is the best we can do under the circumstances. Measures of variation. Variation tells us how far away we are from the mean, typically. And the range is going to be the difference between the highest and lowest data values. And remember, difference just means that we are subtracting. So if you look at the data set, we had a 100, that would have been the highest, 40 being the lowest, the difference would be 60. So the range for that data set would be 60. The standard deviation is going to stay with us from now on. It's very important. This is the formula for the sample standard deviation. And to figure out the sample standard deviation, obviously you have to know the mean, which is X bar. Then you have to take each individual data value, subtract the mean. You would square that. And you would do that for all of the data values, add them up, and then you would divide by n minus 1, where n happens to be the number of data values. We are going to use the the 84s to figure out the standard deviations a lot quicker. If you were a math major, I would say you definitely need to understand this formula more, understand the geometric relationships and so forth. But for our purposes, the TI-84s will suffice. It'd be much better for us. So first thing you would do is you would go back to that data set, right? You would go back and you would look at the scores. And I'm referring back to these here, the first example. And we're going to try to figure out the standard deviation. So first thing we're going to do is we're going to push the stat button on the calculator. And then we're going to go to edit. And we're going to simply go to, I guess we should go into list 1. If you have items in list 1, all you have to do to clear list 1 is to go to the very top where it says L1 and push clear. Once you push clear, that's going to give you a clean slate. Do not push the delete button. If you push the delete button, it's going to delete list 1 and it's hard to get it back. Well, it's not difficult to get it back, but it does take some work. So just clear it out. And once you clear it out, then you can put the fresh data values in. Once you have all of the data values in, make sure you push enter for that last data value so the calculator knows it's there. Once you have put all of the data values in, you're going to go back to stat. You're going to select calculate, and then you're going to choose one variable stats. Once you select one variable stats, it's going to ask you which list it needs to use. And if you used L1, you will just, it's usually defaulted to L1. You'll just go down and calculate. And notice that we are given a lot of information from one variable stats. So one variable stats is going to be a good friend of ours throughout the semester. Notice it gave us the mean, which is 85.56. And I think we figured that out earlier. Let's see. Yes, we did here, right? 85.56. So once you put a list of values in and you run one variable stats, it will give you the average, it will give you the standard deviation, a lot more. It will give you the median, actually. If you scroll down, use the scroll down button, it will tell you the median. I think it's, on most calculators, it's MED. So make sure you're familiar with how to generate, to input data sets and then to generate the one variable statistics. The variance is important, and to find the variance, we simply square the standard deviation. So 18.10 is what I got for the standard deviation, and if you square that, the variance is 327.61. Okay. Now for one of the most important concepts in statistics. This is the bell curve. Most of us recognize the bell curve from high school, right? Usually in high school, we have a little lesson on statistics, but that's the bell curve. Notice that it's balanced, and the main thing is to know that there's a fairly accurate underlying principle with the standard curve, the normal curve, and that is this: 68% of your data will lie within one standard deviation of the mean. 68% of your data, if it's normal, right, will fall within one standard deviation of the mean. And 95% of all of the data will be within 2 standard deviations from the mean. And then finally, 99.7% of your data will be within 3 standard deviations, which means pretty much all of the data points are going to be within 3 standard deviations from the mean. And remember, everything depends on the mean, right? How far away from the mean are we? So let's look at an example. The heights of men have a mean of 69 inches, which happens to be my height actually, and a standard deviation of 2.8 inches. Okay. So let's use the empirical rule, right? The empirical rule is the 68, 95, 99, 7 rule. What does that mean? Well, if I take the average, and I add, let's say this is the average, 69 inches. If I add 2.8 inches, then I end up at 71, right? If I subtract 2.8 inches, then I end up at 66.2. Okay, so this is going to be one standard deviation away from the average, right? So that means that 68% of the men are between 66.2 and 71.8 inches, right? 68% of the men, assuming the heights are normally distributed, are going to be in this area here. I apologize for the crude artistic work here, but that's the best I can do with what I have at the moment. So if I add, so let's see, let me put a 1 here. That means this is 1 standard deviation above the mean. This is 1 standard deviation below the mean. If I add another 2.8 and subtract another 2.8, then I end up at 74.6 on the high end and 63.4 on the low end. Well, that means that 95% of all men are in this range, the 63.4 and 74.6 inch range. And finally, let's add another 2.8 and subtract another 2.8. And what does that tell us? It tells us that pretty much all men are somewhere in this height range, right? Pretty much all men are within 3 standard deviations from the mean. Okay? I probably shaded a little too much on the tails, but you get the point, I hope. So 99.7%, pretty much everyone is between 60.6 and 77.4. I shouldn't say everyone, I should say all men, because this is only referencing men. So if the heights are normally distributed, then we can use the 68, 95, 99, 7 rule to figure out the percentage of the population that fits within a certain height range. Okay. Another important concept. Any data values that are more than 2 standard deviations from the mean are considered unusual. So people who are in this range, right, 77.4, well, actually, let me say this. If you are more than 74.6 inches, or if you are less than 63.4 inches. If you are in these ranges here on the tails, that's considered to be unusual because you are more than 2 standard deviations away from the center, right, from the average. So you are either unusually tall if you're on this end, or unusually short if you happen to be on this end. My father is actually unusually tall, and if my mother were to be included, she would be unusually short. One of the fundamental concepts in elementary statistics is the Z-score. And the Z-score, a lot of students at first do not like the Z-score. In fact, they may never like the Z-score, but the Z-score is actually a helper. It helps us to standardize our data, and it makes it easier to draw conclusions. For example, suppose you have 3 students taking a test on a sense of humor, whatever that means, and then after the laughter dies down, the score is calculated. So think about, I guess, maybe 3 comedians or something coming out on stage and telling jokes, and people record, I guess, how long the audience laughs, and they get a score. So the first person scores a 144. So that would be his data value, and the average for those who are competing in his group is 128. So he's clearly above average. But how far above average is he? Well, the Z-score will tell us. So we take the data value, which is 144, we subtract the 128, which is the mean, and then we divide by the standard deviation, and we realize that he is almost between 0 and 1 standard deviation, almost in the middle, between 0 and 1 standard deviation above the mean. In fact, he is 0.471 standard deviations above average. The second person scored a 90, and the average in his group is an 86. So he's also above, right? He's also above average. The standard deviation is 18. So again, we take his score, subtract the average from that score, and then we divide by the standard deviation, and we get 0.222. So he's a little closer to 0. Okay, so far it appears to me that the student in the A group here, relatively speaking, has done better, right? Almost, actually more than, let's just say he's done twice as well and a little extra than the second person. But the third person here, we might be a little bit confused about this because he scored an 18, but the average in his group was a 15. He's also above average. Well, let's figure out his Z-score. Well, we're going to take his average. We'll subtract the the mean, which is 15, we'll divide by the standard deviation for his group, and 0.6. Okay, he scored the lowest, but for his group, he actually, relatively speaking, scored higher, right? He has a 0.6, so he is definitely one of the standouts in his group. So relatively speaking, even though he scored less than the other students, if you looked at him, you know, if you examine him in the context of those in his group, he did better. All right, percentiles. Percentiles, I will just say this, there appears to be lots of different ways to calculate percentiles depending on which textbook you use. So I'm going to caution you a little bit about using different textbooks or maybe Googling how to find percentiles, because the way we do it is in my opinion, the simplest way. So let's look at this table here. This table has, I guess some researchers have counted the number of chocolate chips inside of the Chips Ahoy cookies, right? And they were nice enough in the table to arrange these from the lowest number of chips, 19 to 30. So let's see, we had two chips that had we had two cookies with 19 chips, and we had what, 1, 2, 3, 4 cookies that had 20 chips, and so on. One cookie had 30, right? The highest. That's the one I would want. But anyway, we would like to know that we would like to know the 23rd percentile. Well, let me think about that again. Let me read the problem. It says, from the sorted list of chocolate chip counts in the table, we see that there are 10 cookies with fewer than 23 chocolate chips. Okay. So where are the 23 chocolate chips? Well, all of the 23 chocolate chips are the first, at the beginning of the second row, right? But if we want to know how many cookies have less than 23 chocolate chips, that would be this entire first row. Okay. So let's say there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cookies have less than 23 chips. So 10 out of 40, because we have 40 data values. If we take the 10 that are less, divide by 40, that gives us 0.25. And if we multiply that by 100, then that gives us 25. So that means that if you happen to have 23 chips in your cookie, good for you, because you have more. Your cookie has more chocolate chips than 25% of the other cookies. All right. And we'll just, here we go. A cookie with 23 chocolate chips is in the 25th percentile. This can be interpreted loosely as a cookie with 23 chocolate chips separates the lowest 25% of cookies from the highest 75%. Okay. For the video, I'm not going to go into great depths on how to find percentiles. For example, if you want the 18th percentile, going back to the cookies, you simply take 0.18, which is 18% of the 40 cookies. That would give you 7.2. And for percentiles, we would round up to 8, and so on. I'll leave that to you. We don't really do a lot with quartiles. A quartile means basically the first quartile is the first 25% of the data values. The second quartile is going to be the bottom 50% from the top 50%. The third quartile, that's going to separate the bottom 75% from the top 25%. So in a nutshell, that takes care of the measures of center and percentiles. I hope this video is helpful, and I encourage you to work diligently in my math lab to continue to keep up with the due dates. Ask questions as needed. Remember, I always reserve time after every lecture to answer questions. Nobody leaves, I'm the last one to leave the classroom, so please stay back and ask any questions. I want you to do well. Thank you.